This is the answer key for the Unit 2 exam in Math 1111, and I'm in D2L in the quiz in the preview mode. And so I want to kind of work through each question with you so you'll have an answer key. So question 1 says, select all of the transformations that have been performed on the basic algebra parent graph to create the function. And you have the function f of x equals negative, the opposite or the negative of the quantity x plus 2 squared plus 4. So I want to go out. I've copied that function over to a Word document, and I want us to talk about what the transformations would be, and then we'll go back and mark our answers. Okay, so typically what we want to do is we want to identify the vertical translation, the horizontal translation, whether there is a reflection on x, whether there is a reflection on y, and then also whether there is a vertical stretch or shrink, which they refer to as compressed. And so if we identify the players in the problem, remember A is the number out front, which is an understood 1 here. It's actually -1. B is the number inside the grouping symbol with the X. H is the constant, and then K is tagged at the end. Hopefully you remembered, since you were using your notes and things, that K tells you the vertical translation. So it's +4, so we went up 4. The horizontal translation is determined by H. And so I encourage you to take the expression inside the grouping symbol, x plus 2, and solve for x to avoid making an error in terms of whether you should go right or left. Since when we solve for x, we get a value of -2, that lets me know that I'm going to go left 2 units. Reflection on x is determined by the sign of A. Since A is negative, there is a reflection on x. Reflection on y is determined by the sign of B. B is positive, so there is no reflection. Vertical stretch or shrink is determined by the numeric value of A, which is 1, so there is no vertical stretch or compression. So when I go to mark my answers, I need to mark up 4, left 2, and reflection on x. Okay, so we went up 4, excuse me. Something's crazy going on. Let me go back to my preview mode. Okay, give me just a second. Okay, so we went left 2, reflected on the x, and up 4. So I've marked those answers. So then we move to question 2. It's another question where you have to select all the transformations. Again, I transferred it over into a Word document so we could talk about it. The function was f of x equals 2 times the square root of the opposite of x plus 1 minus 3. And again, you need to be able to tell me the vertical translation, the horizontal translation, whether there's a reflection on x, whether there's a reflection on y, and then is there a vertical stretch or shrink. Again, if we identify the players, A is the number out front, which in this case is 2. B is inside the grouping symbol with the x, which is -1. H is the constant inside, which is +1. And then K is tagged at the end. So if we think about our transformations, remember the vertical transformation is determined by K, Since it's minus 3, we go down 3 units. Then the horizontal translation, and this is one that a lot of you guys missed, and I think you missed it because of this negative on the B. Okay, and that's why I encouraged you to go off to the side and solve negative x plus 1 equals 0. If I solve that particular expression for x, you'll notice that we get a positive 1, which means we actually are going to the right one. The reflection on x is determined by the sign of A. Okay, reflection on x is determined by the sign of A. A is positive, so there's no reflection on x. Reflection on y is determined by the sign of B. B is negative, so there is a reflection on y. Vertical stretch or shrink is determined by the numeric value of A. In this case, A is 2, which is greater than 1, so there is a stretch vertically. So when I go to mark my answers, I'm going to have 4. I should mark down 3, right 1, reflection on y, and a stretch vertically. Okay, so I had reflection on y. It is stretched vertically. We went down 3 and right 1 unit. Okay, a lot of you wanted to say left, but be careful. Watch your signs. Okay, then we move to question 3. It's another transformation where you have to identify the transformations. Okay, so again, I took that and I moved it over to a Word document. So the third equation or function that you have is f of x equals 1/2 times the absolute value of x minus 2 and then added to 1. And again, we have to identify the vertical translation, the horizontal translation, the reflection on x, reflection on y, and whether there's a vertical stretch or shrink. So again, if I go back and I identify the players, remember A is the number out front, B is inside the grouping symbol with the X, which is an understood 1, H is the constant inside the grouping symbol, and K is tagged at the end. The vertical translation is determined by K, which is plus 1, so we go up 1. Horizontal translation is determined by H. Again, I would tell you to take x minus 2 and solve for x to avoid any kind of error. We get x is positive 2, which means we're going to go right 2 units. Reflection on x is determined by the sign of A. A is positive, so there's no reflection. Reflection on y is determined by the sign of B. B is also positive, so there's no reflection on y. Vertical stretch or shrink or compression is determined by the numeric value of A. A is positive 1/2. Since it's less than 1, there is a shrink or what's called a compression vertically. So when I go to mark my answers, I'm going to mark up 1, right 2, and compressed vertically. Okay, so let's see. Compressed vertically, right 2, up 1. Question 4, again, is another transformation. And the function is f of x equals negative 2 times the cube root of negative x plus 3 minus 1. Again, you want to identify your vertical transformation, your horizontal transformation, whether there's a reflection on X, whether there's a reflection on Y, and is there a vertical stretch or shrink or compression. So again, I'm going to go and identify my players. A is the number out front. B is inside the grouping symbol with the X. H is the constant inside the grouping symbol. And then K is tagged at the end. K here is my vertical translation. It's -1. So we're going to go down 1 unit. Again, a lot of you missed the horizontal translation. Again, that's why I encourage you to take the expression, in this case, -x plus 3, and solve for x. We add x to either side, so 3. I end up with a +3, which means we're going to the right 3 units. Reflection on x is determined by the sign of A. A is negative, so there is a reflection on x. Reflection on y is determined by the sign of B. B is negative, so there is a reflection on y. Vertical stretch or shrink is determined by the numeric value of A. And A is 2 as a number, and that's bigger than 1, so there is a stretch vertically. So I really got a lot of things going on here. So I'm going to wind up marking 5 things. Down 1, right 3, reflection on X, reflection on Y, and stretched vertically. Okay, so I'm going back to my quiz. We reflected on Y. We stretched it vertically. We went right 3 units, down 1 unit, and we also reflected on X. Okay, one more of those type problems. So our function for the 5th one was -1/3 times the quantity x plus 1 raised to the 3rd power, and then add 2. Okay, so again, we're doing our vertical translation, horizontal translation, whether there's a reflection on X, whether there's a reflection on Y, and is there a vertical stretch or shrink. Let's identify the players. Okay, so we have A is the number out front, B is inside the grouping symbol with the X, H is inside the grouping symbol, and then K is tagged at the end. K identifies our vertical translation. It is up 2 because it's +2. My horizontal translation determined by H. Again, if you'll take the expression x plus 1 and solve for x, you'll avoid making a directional error, whether to go left or right. It ends up being a -1, so we're going to go left 1 unit. Reflection on X is determined by the sign of A. A is negative, so there is a reflection on X. Sign of B determines the reflection on Y. B is positive, so there's no reflection on Y. Vertical stretch or shrink is determined by the numeric value of A. A is 1/3, which is less than 1, so there is a compression or a shrink. Okay, so when I go to mark my answers, I've got to mark up 2, left 1, and a vertical compression. So I have up 2, compressed vertically, and left 1. All right, then we move into the next section. And guys, I tried to provide headers here. This one says operations and compositions on functions. So I tried to give you a header so you could maybe go to your notes on that particular topic to help you out. So question 6 asks you to take the 2 functions f of x, which is 3x squared plus 4x minus 7, and then function g, 6x minus 4, and it wants you to perform the subtraction. Okay, so I may need to go out to the side here. I don't believe it'll let me do it on that screen, so let me carry it over and get us a clean sheet of paper. Okay, so the problem asks you to do f minus g at x. Okay, so you're going to plug x into f, get the answer, plug x into g, get the answer, and then subtract the two results. Okay, so, and it's really important, that's a lot of you make a sign error. So let me go back and get function f. F is 3x squared plus 4x minus 7. Okay, so function f is 3x squared, I forgot whether it's minus or plus 4x minus 7. And then I need to get function g. Function g was 6x minus 4. Okay, and then I want to subtract those two things. Well, if I'm going to subtract those two things and avoid a sign error, I need to remember to distribute this -1. Okay, so I would have 3x squared plus 4x minus 7 minus 1 times 6x would be minus 6x. Minus 1 times minus 4, minus times a minus makes plus 4. Okay, then I come back and I combine like terms. Okay, there's nothing to combine with 3x squared. I have plus 4x minus 6x. 4 minus 6 gives me minus 2x. Then I have minus 7 plus 4, different signs subtract. 7 minus 4 is 3, take the sign of the larger. So my result is 3x squared minus 2x minus 3. Okay, so 3x squared minus 2x minus 3. Question 7 is another one of those questions, and it's asking us to do multiplication. So they give us function f, which is 3x squared plus 2x minus 5, and then they give us g, which is x minus 4, and it wants us to do the multiplication. Okay, you have f, g written side by side, which is the multiplication. So I'm going to go out to my scratch paper. I'm going to have to get me another clean sheet. And I want to do f times, oops, sorry about that. I want to do f times g at x, which means I'm going to substitute x into f, get the answer, sub x into g, get the answer, and then I'm going to multiply the two results. So function f was given to me in the problem as 3x squared plus 2x minus 5. Function g was given to me in the problem as x minus 4. And then I'm going to multiply those two results together. Now, to multiply the two results together, we have to use the distributive property. So I'm going to do 3x squared times x which gives me 3x to the third. 3x squared times minus 4 is minus 12x squared. Then I go back and I'm going to change colors, and I've got to do positive 2x times everything. So positive 2x times x would be positive 2x squared. Positive 2x times minus 4 would give me minus 8x. And finally, I have to do the minus 5. So I have minus 5 times x gives me minus 5x. Minus 5 times minus 4 would be plus 20. And then at the last step, I come back and I combine like terms. So there's nothing to go with my 3x cubed. Minus 12x squared plus 2x squared is minus 10x squared. Minus 8x minus 5x is minus 13x. And then the plus 20. So ultimately, I have 3x cubed minus 10x minus 13x plus 20. Going back out and I'm looking for that answer. Let's see. 3x minus 10x minus 13 plus 20. Question 8 is a composition problem. It's asked you to do F composed with G at x, and it tells you that f of x is x squared minus 3x plus 3, and g of x is 2x minus 3. Because with the composition, and I know it's a composition because of that little circle there, so we're going back out and looking at question 8, and we want to do F composed with G at x. Now remember this is a kind of a different concept than just adding, subtracting, or multiplying. Okay, because this means I'm going to take the x and substitute it into G. And G was 2x minus 3. I then take that answer that I get and I substitute it into function f, where f is an x. So into function f, and I'm going to try to use colors here where you can see it. I would have x squared minus 3 times x plus 3. Well, in place of x, I have to put this 2x minus 3. So I really have the quantity 2x minus 3 squared minus 3 times the 2x minus 3 added to 3. And then you got to do the algebra. You guys remember that 2x minus 3 squared, that's really 2x minus 3 times 2x minus 3. You have to pull it out, which gives us 4x squared minus 6x minus 6x plus 9. When you pull that particular expression out. Then I need to distribute the negative 3. So I've got to do negative 3 times 2x, which is minus 6x. Negative 3 times negative 3, which is positive 9. And then I still have the plus 3 as part of the original function tagged at the end. And so the last step is to combine like terms. So I have nothing to pair with my 4x squared. But I have minus 6x minus 6x minus 6x minus 6 and 6 make 12, and 6 more make 18. So I have negative 18x. I have plus 9, plus 9, plus 3. 9 plus 9 is 18, plus 3 is 21. So the answer is 4x squared minus 18x plus 21. Question 9 asks you to do an addition problem of the function f, 3x cubed plus 3x squared minus 8x plus 9, and function g, which is x cubed minus 2x squared plus x minus 8. So we're going to do the addition problem. Okay. So I'm going to go back and use this piece of paper. All right, so our question is to do f plus g at x. So we plug x into f, get the answer. Plug x into g, get the answer, and then add the two results. So I was given function f. Function f is 3x cubed plus 3x squared minus 8x plus 9. Then I plug x into function g. Function g was given as x cubed minus 2x squared plus x minus 8. Okay, and then to add them together, we combine like terms. So I would have 3x cubed plus 1x cubed makes 4x cubed. 3x squared plus negative 2x squared, different signs subtract, gives me 1x squared, and it's positive. Negative 8x plus 1x. 8 minus 1 is 7, and it's negative, so I get negative 7x. And then you have plus 9 minus 8, which leaves me with plus 1. So ultimately, I have 4x cubed plus x squared minus 7x plus 1. Okay, so going back. I believe it was this one. Let me double check. Nope, that was my subtraction. Hold on. I get the right. Plus x squared minus 7x plus 1. Yep. Okay, then the next grouping of questions dealt with inverse functions. And I gave you a table which shows the year and the number of North Atlantic tropical storms or hurricanes. And I asked you the question, does the function represented by the table above have an inverse? In other words, is the table 1-to-1? Okay, so I tell you initially that it's a function. And so all you're really trying to decide is it 1-to-1? To determine if it's 1-to-1, you want to make sure there's no repetition in the y values. Okay, well, if I look at this list of y values here, I notice immediately that the 7 repeats. I also note that 12 repeats and 15. So that tells me that this particular function is not 1-to-1 because there is a repetition in the y values. And guys, if I'm not mistaken, that question was on the review sheet. Question 12 asks you the same thing, and I give you the table of the year and the World Series winner. Excuse me. It says, does the function in the table above, again, I tell you it's a function, have an inverse? Is it 1-to-1? And again, so I want to look for, is there a repetition in the y values? And if I look, we have San Francisco, Kansas City, Chicago, Houston, Boston, and Washington. There is not a repeat in the y values. Therefore, that function is one-to-one and would have an inverse. Question 12, Ms. Ralston made an error on the answer key, and so I've gone through everyone's exam individually and corrected it, but it asks you which image is the graph of a function that is one-to-one, which would have an inverse. And remember, to be one-to-one, it has to pass the horizontal line test. Well, if I look at this first option, it would not pass the horizontal line test because at some points I may cross 4 times. Similarly, with the second option, I would cross about 4 times. The third option, this curve, and again, remember we talked about it, how that there, even though it looks flat, it never becomes truly horizontal. This is the correct answer, okay? And it just so happens that it copied itself in red instead of blue. So, but then the other one, if you look at this parabola down here, it would cross 2 times. I had mistakenly marked it as the correct answer, but again, I've corrected that on your test paper. The correct answer is this red curve there. Question 13 gives you a one-to-one function, f of x equals 3 plus 2x, and it asks you to find the inverse. So I tell you outright that it's one-to-one, and I then ask you to find the inverse. Okay, so I'm going to go out, get us a clean sheet of paper. My original function is f of x equals 3 plus 2x. Now, hopefully you can recognize that as a line. And all lines are one-to-one with the exception of a horizontal line. So I'm going to find the inverse. And remember, to find the inverse, the first step is you interchange x and y. Remember, in this function, the f of x represents your y. So in the first step, I'm going to interchange x and y. So I'm going to rewrite this as x equals 3 plus 2y. And then I have to solve for y. So first off, I'm going to subtract 3 from every side, both sides, to isolate the y. So I have x minus 3 equals positive 2y. Then I need to divide both sides. Whoops, going crazy. Divide by 2 on both sides. So I end up with y equals the quantity x minus 3 all over 2. Once you have it solved for y, remember this y now represents f inverse. So my inverse is x minus 3 all divided by 2. So let's see, x minus 3 all divided by 2. Question 14 also asks you to find the inverse of a one-to-one function, and it gives you the function as the cube root of 5x minus 2. Okay, so again, I'm going out to my paper. All right, and again, we have our original function is f of x equals the cube root of 5x minus 2. Again, remember in this scenario that f of x represents y. You were told it was one-to-one, so we know it has an inverse. And in the first step, we interchange x and y so that this becomes x equals the cube root of 5y minus 2. And then ultimately, I've got to solve that expression for y. So the first thing I'm going to do is I need to get rid of this cube root. We undo the cube root by cubing. And so I have to cube both sides so that I have x cubed equals 5y minus 2. Again, remember, I'm trying to solve for y, so I need to isolate it. So I'm going to add 2 to either side to get the y by itself. So we have x cubed plus 2 equals 5y. But I don't want 5y. I just want plain old y. So I'm going to divide both sides by 5 so that I have x cubed plus 2 all divided by 5 equals y. But remember that y, once you solve for y, that y represents f inverse. So we need x cubed plus 2 all divided by 5. All right, question 15 asks you which is the graph of the inverse. And guys, this is where you have to kind of look at the graph and remember to do the flip-flop on the ordered pairs. So it looks like this particular curve on the original one begins at the ordered pair 2, 0. Okay, and so remember on the graph, and I'll go over and make you a note about it. If on the original graph, we have that ordered pair 2, 0, that means on the inverse, we're going to have the point 0, 2. Let me see if I can locate another point off of that graph. It also looks like it goes through the point 3, 1. Okay, so if I have the point 3, 1 of the original, I'm going to have 1, 3 on the inverse. Remember, you flip-flop the ordered pairs. Okay, so I'm looking for a graph that has the points 0, 2 and 1, 3. Okay, so that has 0, negative 2, so it's not the first one. The second one has negative 2, 0. It's not the second one. The third one looks promising because I have 0, 2, and I also have 1, 3. So it's the first one, or the third one, excuse me. If you want to check the fourth one is still at 2, 0. So it doesn't fit. All right, then we move to the next group. The next group is linear functions. And again, I have it clearly labeled as linear functions. Okay, and so let me get rid of some of these pages so that we don't get confused on what we're looking at. And the first question, 16 there, asks you to find the slope of the line passing through 5, negative 4, and 3, 2. Okay, so we have the ordered pairs that are given to us. We have the ordered pair 5, negative 4, and the second ordered pair 3, 2, and we're asked to find the slope. So I hope you took the time, if you didn't know it from memory, to look up your slope formula, which is m equals y2 minus y1 over x2 minus x1. And x1, y1 represents one of the points, and x2, y2 represents the other point. So I like to label my points. So I have x1, y1, x2, y2. And guys, at that point, it's a plug and chug. Okay, we plug the numbers into the formula over here and do the calculations. So I would have 2 minus -4, and I'm going to write it out for you, over 3 minus 5. Okay, minus a minus, guys, remember, gives us a plus. So this becomes 2 plus 4 over the 3 minus 5. And if I do the math, 2 plus 4 is 6. 3 minus 5 is -2. 6 divided by -2 is -3. So the slope between those 2 points, of the line between those 2 points, is -3. All right, then question 17 asks you to write the equation of the line that passes through -10, 3 and has a slope of 1/5. So now we're kind of into the equations, or the questions where it's asking you to write the equation of a line. And again, remember, I mentioned to you on last Wednesday that I hoped that what would trigger in your mind when you saw that phrase is that you had to know the slope, a point, and you had to use the point slope form. So in this particular problem for 17, I'm given the slope and a point. And so it's going to be a matter of substituting into our point slope equation. Okay, so for question 17, we want to write the equation of the line that has a slope of positive 1/5, that was given to us, and passes through the point -10, 3, which was also given. Again, I hope you took the time to look up your point slope formula if you didn't know it from memory. It's y equals m times the quantity x minus 1 plus y1. And again, at that point, guys, it becomes a straight flat out plug and chug because I have the slope, then my ordered pair is x1, y1. So if I substitute in, I have y equals 1/5 times x minus the minus 10 really is plus 10 plus 3. And then if you look at your answers, if you go back and look at all of your answers, and it doesn't tell you to put it in slope-intercept form, but if you'll notice, all of your answers are in slope-intercept form. The other thing that you could or should have done is maybe eliminate some of your choices. There are really only 2 equations here where the slope is 1/5. So it's either got to be the first one or the fourth one. So if it came down to you guessing, I hope you could narrow it down to those 2 and have had a 50-50 chance. But you really don't have to do that, guys, if you will do the math. Okay, so I need to simplify this by eliminating the parentheses. So I have y equals 1/5 times x is 1/5 x, 1/5 times 10. If I come over here to the side, 1/5 times 10 over 1 is 10 over 5, which is ultimately 2. And if you couldn't do that in your head or on paper like I just did, guys, please get the calculator out and do it. Don't make crazy errors because you don't want to take the time to get the calculator. And so then I come back and I combine like terms and I get y equals 1/5 x plus 5. Positive 2 plus 3 is plus 5. And so having narrowed my choices down, I now know that it's going to be the first one. All right, question 18 again ask me to write the equation of the line passing through the points 2, 3, and 5, 7. And again, as I mentioned to you last week, when you see that phrase, write the equation of a line, you want to think, I need the slope, a point, and I need to use point slope. Well, in this particular problem, you didn't, you weren't given the slope, but we have enough information that we can find the slope. Okay, because I am given in the initial problem 2 ordered pairs. Okay, so initially they give me the 2 ordered pairs, 2, 3. Okay, let's just get a clean sheet of paper. Okay, initially they give me the ordered pairs 2, 3, and 5, 7. So with those 2 ordered pairs, I have enough information that I can calculate the slope because I have x1, y1, and x2, y2. So using my slope formula, which is y2 minus y1 over x2 minus x1, I would have 7 minus 3 over 5 minus 2, which gives me 7 minus 3 is 4. 5 minus 2 is 3. So I get a slope of 4/3. So then I'm going to use that slope value that I just calculated in one of my points, and I'm going to use the point 2, 3. It really doesn't matter. And I'm going to substitute into the point slope formula. So I have y equals 4/3 times x minus 2 plus 3. And again, if I go back and I look at my answers, they're all in slope-intercept form. I also should be able to narrow my answers because there are only 3 of them where you have a slope of 4/3. So I could at least narrow it to those 3 options if it came down to me guessing. Okay, so then I'm going to do the distributing so that I have y equals 4/3 times x, 4/3 times -2. Okay, that's going to give you 8/3. So I have minus 8/3 plus 3 wholes. Okay, and then I need to combine those like terms, which, yeah, may be a little challenging. Get your calculator out. 4/3 x. Okay, so 3 pizzas with 3 slices each, I would have 9 slices. 3 pizzas, 3 slices each, I have 9 slices. So I have -8 plus 9/3, which gives me positive 1/3. So I end up with 4/3 x plus 1/3, which is the last choice here. Question 19 is the same type question, and they give us the ordered pairs -5, 6, and 2, 1. Okay. So I'm going to clear some of these off of here so we don't get messed up. Okay, and I'm going to get us a clean sheet of paper. And we start with the 2 ordered pairs that they give us, which are -5, 6, and 2, 1. Again, we're asked to write the equation. So hopefully you remember that you have to know a point and the slope and use point slope. So the first thing that I have to do here because I wasn't given the slope outright, is I have to calculate the slope using the points that I was given. So we have the point x1, y1, and x2, y2. So I'm going to plug and chug. I'm going to substitute into my slope formula. So I would have 1 minus 6 over 2 minus a minus 5 makes plus 5. So I have negative 5 over 7. So my slope is negative 5/7. So again, I could come over here and kind of eliminate some of my choices. I have 2 options left. So I'm going to go over and do the math. So I'm going to plug in to point slope, which is y equals m times x minus x1 plus y1. So my slope, I have y equals negative 5/7 x minus the minus 5 is plus 5 plus 6. And again, my answers I noticed were in slope-intercept form, so I need to distribute and collect like terms and so forth. So we have y equals negative 5/7 x, and then we have negative 5/7 times 5, which gives us negative 25 over 7. Plus the 6. And so then I need to combine the like terms. And so I have 6. So I would have 6 pizzas with 7 slices each. So let's see what I got. Okay. 6 pizzas, 7 slices each. I would have 42 slices. I have different signs, so we're going to subtract. Okay, so 42 minus 25 is 17. So when you combine these two things together, we end up with y equals negative 5/7 x plus 17/7. Okay, so negative 5/7 plus 17/7. All right, question 20 still asks you to write the equation of a line, but I even put it in caps, hoping you wouldn't miss it. But you want it to be parallel to the given line, which is 5x minus 7y equals 2. And you're going to write the equation so that it passes through the point 3, 4. Okay, so let's think about this. Okay, a couple of things. I want to be parallel to the line 5x minus 7y equals 2, and I want to pass through the point 3/4. Okay, so remember, to write the equation of a line, you have to know the slope, and in this case, it has to be the parallel slope, a point, which you're given, and then we're going to use point slope. So the first thing I need to do here is determine the slope. And to determine the slope, we can take this equation here and solve for y. If we take that equation and put it into slope-intercept, I can easily tell you what the slope of the function is, or of the line is. So we need to solve for y. So I'm going to subtract 5x, I have negative 7y equals negative 5x plus 2. I'm then going to divide everything by negative 7. So that you have y equals positive 5/7, because negative and a negative make a positive, x, positive and a negative make a minus 2/7. Once you have it in slope-intercept form, remember your slope is the number in front of the x. So the slope of the given line is 5/7. So, and we remember that parallel lines have the same slope. Okay, so the slope of the line that I need to create should also be 5/7. So using that parallel slope and the point slope equation, okay, we're going to write the equation of the line. So using point slope, y equals m times x minus x1 plus y1. So I would have y equals 5/7 x minus 3 plus 4. And again, if I look at my answers, okay, I have two answers that have 5/7. And so if I had to guess, that's what I've got a 50-50 chance. All right, so let's see if we can finish working this out. So I need to distribute so that I have y equals 5/7 x minus, because it's a positive times a negative, okay, 5/7 times 3/1 is 15/7. So I have minus 15/7 plus 4 wholes. And so then I need to combine those together. So I'm going to think about my math here. Okay, so I have 4 pizzas, 7 slices each. Four pizzas, 7 slices each. So I would have 28 slices. And I have different signs, so we subtract. 28 minus 15 is 13/7. Use the sign of the larger, it's positive. So we end up with y equals 5/7 x plus 13/7. All right, question 21, Miss Ralston really made a big mistake because actually none of these answers are correct. Okay, none of these answers are correct. So that's my fault. So everybody got credit for this problem, but I'm going to go ahead and work it out for you. Again, you're asked to write the equation of the line, but again, I capitalized it and said to make sure that it was perpendicular. And you wanted it to pass through 2, 3, and 6, 9. So again, when you're thinking about this, you're given 2 points, okay? So you're given the 2 points, 2, 3, and 6, 9. And ultimately, you're asked to write the equation of the line that is perpendicular to the one that goes through those 2 points. So again, remember, you need the slope, specifically the perpendicular slope, a point, and then we use point slope. So the first thing I have to figure out, because I'm not given the value of the slope, is I need to figure the slope of the given line. So the slope of the given line, if I use my formula, here's x1, y1, x2, y2. Okay, so I would have y2 minus y1, x2 minus x1 equals 9 minus 3 over 6 minus 2. So 9 minus 3 is 6. 6 minus 2 is 4. That gives me 6/4, which would simplify to 3/2. So the slope of the given line is 3/2. But remember, we want the perpendicular slope. In perpendicular slope, we would have the negative reciprocal. To find the negative reciprocal, you flip it, so it becomes 2 over 3, and you change the sign. It's originally positive. I make it negative. So the slope that I need for working the problem is negative 2/3. Okay, so now I have my perpendicular slope. I have a point, so I'm going to substitute into point slope. So y equals m times x minus x1 plus y1. So I have y equals negative 2/3 x minus 2 plus 3. And again, I need to simplify that into slope-intercept form. So distributing the slope, negative 2/3 times x minus 2/3 times minus 2, negative times a negative is a positive. 2/3 times 2 is 4/3. Okay, so I have 4/3 plus 3. So I have 3 pizzas, 3 slices each. So I have 9 slices total. 9 plus 4 is 13. So the actual answer is negative 2/3 x plus 13/3. Again, on the actual test, you won't find this answer. Miss Ralston made a typographical error. Okay, so I gave everybody credit for that particular problem. I went through each individual test and gave you credit. All right, then the last grouping of questions is the imaginary and the complex numbers. Square root of -9, okay, because it's negative under the radical, we know we're going to have an I, and the square root of 9 is 3, so I have 3I. Simplify square root of -25. Again, because I have a negative under the radical, I know I'm going to have an I, and the square root of 25 is 5, so it's 5I. All right, -12, square root of -12 may not be as obvious, so let's go over to a sheet of paper. Okay, let me get a clean sheet. And let's talk about the square root of -12. Okay, square root -12. Again, first off, if you want to break this apart, you can. Okay, so I would have -1 times 12. And I know because of the -1 under the radical, I'm going to have an I. So I get I square root 12. But I can't stop there because remember, you have to ensure that you don't have a perfect square under the radical. Well, 12 is 4 times 3. 4 is a perfect square, so it's going to come outside. The square root of 4 is 2. I still have the I because it was negative, and the 3 has to remain under the radical. So when you simplify square root -12, you get 2I square root 3. Again, the I is there because, whoops, not negative, because you have a negative number. And then questions 25 and 26, it kind of combines some concepts together. So we have the square root of 64 minus the square root of -16 plus the square root of -81. And you're basically asked to simplify that particular expression. Okay, so let's see if we can do that. Okay, something funky is going on with my computer. So hang on just a second. I want to try to finish this. Okay. I don't know what's going on. Okay, so I'm going to give you the answers. Then if you need to see them worked out, I'll work them out later. This one would be, let me see, I would have 8 plus 5i. And then the last one would be 11 plus 4i. So at least you have the answer. Something's going on with my computer and it's not letting me go over to the Word document, but at least you'll have the answers. Okay, so you may want to take a look at, I'll release the exams where you can look at them and see how you did.